Solve the system of equations. Here's our system, and it's made up of two equations. We're going to go ahead and use the elimination method. There's a substitution method. For this problem, we'll use the elimination method. So first, make sure that the x's and y's are on the same side of the equation and the constants on the other side of the equation. Notice how we have the x and the y terms on one side of the equation and the constants on the other side of the equation. You first make sure that's the case. Notice how the x's are lined up in the same column, the y's are lined up, and the constants are lined up. Now, we could work on this equation so that we won't have to work with fractions. We could simplify this equation. We're going to clear it of fractions. So how do you clear it of fractions? Look at the denominators and then ask yourself, what number can be divided by 3 and 4 evenly? There are many numbers. The smallest would be the 12. So you take that number and multiply the whole equation, both sides, by that number, and notice how the fractional look disappears. So it's 12 times this term, 12 times this term, 12 times this term. Simplify, and notice after the simplification, the fractional look has disappeared. Now, you put it back where it was, the equation. That was equation 1. And now we're hoping to eliminate one of the variables and then solve for the other. But notice as we go through column by column and combine like terms, we get zeros each time. And this gives you a 0 equals 0, which is true. So we don't have any variables left, but we do have a true statement. So even though the variables are gone, we could say that 0 equals 0 is true. This case is one of 3 cases. When you get this result where you get a true, you say there's an infinite number of solutions. An infinite number of solutions. Let's go ahead and solve this system using the elimination method. So here's a different system. Notice the x and the y are on the same side, the constants are on the other side. And now we're going to go ahead and clear the second equation of fractions. We'll multiply the whole equation by a 2, both sides of the equation, and we end up with this. So this one is going to replace the second equation. This one's easier to work with. So now this one takes its place as a second equation. And now we go and try to cancel either the x or the y. It doesn't matter. Eliminate one of them. So what we're going to do is going to go ahead and choose the x. You could have chosen the y. So I'm going to choose the x. So I'm going to multiply the second equation by a -2, both sides. And notice what happens when I do that. I get this one. And now when I go through the x combination, it's going to be a 0, and that'll leave me just the y. So I could work with one variable at a time instead of 2. These cancel, and we get y equal 1. So we already have the y. Now we use what we just found to find what's missing. We need the x. So substitute this y that you found into one of the 2 equations. It doesn't matter which one. I'm going to go ahead and substitute it into the first equation. This is the y, it's a 1. Simplify, and notice we could find out what the x is now. So you keep simplifying, combining like terms, getting the x by itself, and we get an x equal 4. So now we know the x and the y. So the solution is 4, 1. Remember, the x is always written first and then the y. That is our solution for that system. Now let's interpret, what does it mean when we solve a system and the result? What does it mean? Well, you have only 3 cases. And remember, each of these lines is represented by an equation. So, as in the very last problem, we came up with a solution. That would be this case, one unique solution set. That means these lines are crossing at one point. If the lines are parallel, we have a no solution case. And the reason we say there's no solution is that solution means point of intersection. There was one point of intersection here, so we have one unique solution. These two lines are parallel, so there's no points of intersection, so no solution. Or like the one that we did first, where we had 0 equals 0, there were an infinite number of solutions. And what that meant, if you were to draw the lines, is that you're actually talking about the same line intersecting itself.